Now we want to take our 7 rules that we looked at and we want to put all these pieces together in order to simplify or verify an identity. Now here we've got a complex identity, and just as what we did last chapter, we want to take the more complex side and make it equal to the simple side. And what we did is we drew a vertical line here right beneath the equal sign, and we said that we could not move pieces back and forth between the two sides. That same process is true, but due to lack of space here, I'm just going to work horizontally, but in your mind you want to be thinking, I cannot move that negative secant of x to the other side. So our more complex side is obviously this left-hand side, and we want to take it and make it more simple. Now we know that everything here is written in terms of sine and cosines on the left-hand side, so that rule doesn't apply. We've got no greatest common factor or foiling that we can do, but I do see that I've got 2 different fractions. And when I have 2 different fractions, the first thing that should come to mind is making a common denominator and combining the fractions into a single fraction. So here, sine of x over cosine of x, if I want to make a common denominator between those 2 pieces, and I want to tie it with this negative cosine of x over 1 minus sine of x, I need a 1 minus sine of x to be added to the denominator of that first fraction. And whatever I put in the denominator, I also have to put in the numerator. For my second fraction then, I've already got the cosine of x, and I've already got 1 minus sine of x. In order to make a common denominator here, I can see I need this additional cosine of x. And whatever I put in the denominator, I also have to put in the numerator. Now I can simplify this down into a single fraction. The cosine of x, 1 minus sine of x being in the denominator. And then in the numerator, in my first fraction, I can distribute the sine in to the 1 minus sine of x, which leaves me sine of x minus sine squared of x. And then in my second piece right here, cosine times cosine gives me a cosine squared. And since there's a minus sign in between, I'm going to have a minus cosine squared. Now the next thing that I see right here, since everything is in terms of sine and cosines, I've got a sine squared and a cosine squared. And there is an identity that we looked at that is sine squared and cosine squared. It was sine squared of x plus cosine squared of x was equal to 1. Now, is there a way I can manipulate this identity so that I have a negative sine squared of x and a minus cosine squared of x? And the answer is yes. If I were to multiply through by a negative all the way through, I can see negative sine squared of x minus cosine squared of x is equal to negative 1. So this quantity right here is the same thing as a negative 1. So I'm going to replace that negative sine squared of x minus cosine squared of x with a negative 1. So my numerator becomes sine of x minus 1 all over the cosine of x 1 minus sine of x. Now if I look at this numerator and this denominator, I can see they're very close to one another. So I'll start by switching my numerator around just so that I've got my sine in the back and the 1 in front. And I can see how close that quantity is. The only thing that's different between the numerator here and the denominator from holding me back from canceling is the fact that this one is negative and this one is positive, and then this sign is positive and this sign is negative. The signs are reversed. So in the numerator, let's factor out a negative 1. Now I've got a 1 minus sine of x in the numerator, and in the denominator, I've got a 1 minus sine of x. So my 1 minus sine of x's cancel out. I'm left with negative 1 over the cosine of x, which is the same thing as negative secant of x. So I've just verified that identity, only manipulating the left-hand side. The second problem we have here is rewriting this expression so that it is not in fractional form. So my goal is I need to somehow get rid of that denominator. And a great way to get rid of a denominator is by using a conjugate. Remember in the previous page how we talked about the conjugate, 1 minus cosine of x? If we use the conjugate, it's 1 plus the cosine of x. And then there's a good chance that my denominator will simplify down using one of the Pythagorean identities. Same thing is going to be true right here. This 1 minus sine of x, if I multiply by the conjugate, which is 1 plus the sine of x, my numerator is still going to remain cosine squared of x, 1 plus sine of x. My denominator, though, I can see if I FOIL this out, is going to become 1 minus sine squared of x. These two factors are the result of the difference of two squares, which is what we have right here, the 1 minus sine squared of x. And from our Pythagorean identity, 1 minus sine squared of x is the cosine squared of x. Now I can see my cosine squared of x's are going to cancel out, and I'm left with 1 plus sine of x. So this expression written in non-fractional form is just 1 plus sine of x.